Welcome to Module 2, Lesson 23, more solving equations using algebra. So like Lesson 22, we will be using algebra to solve problems, as well as comparing those solutions to the steps taken with tape diagrams. If you feel at any given point that you are ready to abandon this presentation and can do all of the problems presented to you in this lesson by yourself, feel free to do so. But if you would like my support in solving these problems step by step, you can watch it from beginning to end. Okay, so yeah, with no further ado, let's get started on that first exercise there. It says youth group trip. Okay, so here we are. Youth group trip. The youth group is going on a trip to an amusement park in another part of the state. The trip costs each group member $150, okay, which includes $85 for the hotel and a 2-day combination entrance and meal plan passes. Okay, and I'm thinking this is our unknown, huh? Because they're not giving us a price on those. Okay, so here we go. A is going to ask you to write an equation representing the cost of the trip. Okay, so this is what our equation is going to represent. Now P is our unknown, as we had mentioned, which is this right here, the cost of the park pass. Okay, we know each member is going to pay $150, and $85 is going to be their hotel. All right, so we have to write an equation. So we're kind of keeping it simple at this point. And if you want to go ahead and do that and come on back, and we could take a look at that. And we'll just start from there, and then maybe from then on we'll just go ahead and have you complete maybe maybe we'll just have you complete a few at a time. So I'll just go ahead. Let's just do A first. Go ahead and pause if you'd like. Figure this out and come on back. Okay, so hopefully you came up with this answer here. 85 is what we know. So 85, that cost of the hotel. Plus we have 2, and hopefully you picked up on this, there are 2 one-day combination entrance and meal plan passes. Okay, so 2 of those. So we're going to need 2 P's. And all of that equals $150. And again, if we made this into a quick tape diagram, we know there are 3 parts to this. We have 85, which we know already, and then we have P, and we know this entire thing. Entire equals 150. So this is what it would look like as a tape diagram. Okay, so we have to fill in for P, and you know how to do that. Okay, but let's go ahead and have you solve that equation algebraically, and that's part B, to find the cost of the park pass, and then write the reason that justifies each step using if-then statements. Now, I'm not as picky about this here, so just go ahead and write it, why you did it, just generally which identity property you used or inverse property you used. Okay, so but the if-then gets a little bit tedious, I believe. So I'm going to pause now, so go ahead and complete that B. Okay, so here's what your solution should have looked like. Okay, so we started off with 85 plus 2P equals 150, and then we go ahead and we apply our subtraction property using the additive inverse of 85. Okay, so because we're trying to again isolate P on the one side, so we have to subtract 85 from the left, do the same on the right. We end up with 2P equals 65 because we have taken these away. I'm not doing the 0 thing because that drives me crazy. Okay, so we're taking away those, and 2p equals 65. But then, of course, we want to get this down to 1p. Right here, we want to isolate that 1 because we want to know, how much each one of these p's is worth. Okay, we want to know because we already know using this tape diagram. We could figure out what those 2 p's are worth here just by going, 150 minus 85. We know we have 65 left. I can tell you right now that those 2 p's equal 65. Okay, but to find out what one of those p's equal, of course, we're going to multiply by 1/2 or divide by 2, and we do that to both sides, and we end up with p equals 32.5. But since we're talking dollars and cents, our answer is $32.50. Okay, and part C of this problem asks you to model the problem using a tape diagram to check your work. Now we've already done our tape diagram up here. Okay, so we've already taken care of that. So, but you can do the same. Okie doke. Okay, so here is the next part of this this exercise here. Suppose you want to buy your favorite ice cream bar while at the museum park, and it costs $2.89. If you purchase the ice cream bar and 3 bottles of water and pay with a $10 bill and receive no change, then how much did each bottle of water cost? Okay, so here are key pieces of information. $2.89 for the ice cream bar. You got these 3 bottles of water. You pay with $10, no change. So that means $10 is your total cost. And then we're trying to find out how much did each bottle of water cost. So this idea of each, we want to know what 1 bottle of water would cost. So go ahead, complete D, E, and F. Same system as we did with the first problem. And come on back and we'll check them out. Okay, so here we are with this problem solved now. So the first part of this problem was to write an equation to model this situation. And as you can see, I've done that up here. I have my known of 289, okay, which I got from my problem there, plus 3W because I have these 3 bottles of water whose price is unknown, equals $10. Okay, now there may be a time where there will be some change, and that would add another little twist to the problem. But for our case now, that's going to cost even $10. Okay, so that's what we start off with. That's our equation. Okay, and next the steps are very similar to what we've done before. We start out with our equation. Okay, our first step is to take that subtraction property of equality and using the additive inverse. So we're going to subtract 289 from this side and 289 from this side. Of course, we're trying to isolate 3W. Now we have 3W equals 711 after doing our subtraction. And now we're going to divide both sides by 3 or multiply by 1/3, which is the same thing. And we do that and that, okay? And if we divide 711 by 3, okay, we get 2.37. Okay, 2.37. All right, so that's that would be our answer there. Do the same here down here, just checking with your tape diagram. Same way, four separate elements to this problem. The one we know already is this one here, the $2.89. We know that's going to be the ice cream bar. Okay. But we don't know the water price, so we do have our 3 W's. We know the whole thing is worth $10. Therefore, the $10 total minus what we know already, 289, gives us 711. And then we divide that 711 by 3 to find out what each one would cost. And we end up with 237. Okay? Okay, so here's our next problem, weekly allowance. Charlotte receives a weekly allowance from her parents. She spent half of this week's allowance. Half of this week's allowance. Okay, I can't, hold on one second. Let me get that to a place where I could actually write on it. Okay, so she spent half of this week's allowance at the movies, but earned an additional $4 for performing extra chores. if she did not spend any additional money and finished the week with $12, what is Charlotte's weekly allowance? Okay. Now this one has a few different elements to it, which is exciting. Makes these things a lot more fun for me and for you. This is kind of taking an extra step here. So why don't you mull that over a little bit and come on back and let me see the equation. Let's just do A. Just start with A. Write an equation that can be used to find the original amount of Charlotte's weekly allowance. Okay, so keeping in mind all of these elements here. Okay, she spent half of the allowance. Okay, she got an additional 4. Okay, and she ended with 12. Okay, now one thing, if you notice right away, you don't know what her allowance is. Okay, all right, you don't know what her allowance is. So that is what we're trying to find out. Okay, so give it a whirl and come on back. Okay, so here we are back, and hopefully you came up with something that looked like this. Don't worry sometimes if you maybe put the 4 in the front, like 4 plus 1/2 A equals 12, or flipped it over, but this is probably the preferable way to do it with your with the amount over here, this 12 on this side, and then and keeping your unknowns on the left. Okay, the best way to approach it. Anyway, let's look at where all these came from. Of course, the 12 came from here because that's what was left over. Okay, so half of the week's allowance. So she spent half of it. It's gone. Okay, we can't account for that, but we can account for the half that's left over because that's still going to be with her. Okay, she had the 1/2 left over. She has another 4. Okay, that she got for doing additional chores. She didn't spend any more money. Okay, so that the half of the allowance and the extra $4, that all equals $12 because that's what she has left over. Okay, and that's using that we can find out what her allowance is, and hopefully you came up with that. So go ahead, and if you didn't come up with that, just go ahead and put that there now. 1/2 A plus 4 equals 12, and then let's go ahead and have you solve the equation B, and then come on back before you do C and D and E. Okay, so here we are back with our problem solved. Okay, just wrote out the problem again right here. 1/2 A plus 4 equals 12. And I'm going to go ahead and apply that subtraction property of equality to find, with the additive inverse of 4. Okay, so here we go. We have 4 minus 4, and of course we're going to subtract that 4 away from that side as well. And then what we're left with there is 1/2 A equals 8. Okay, and if I'm going to go ahead and isolate this A and make this into 1A, where I only have a half, remember I have to multiply by the reciprocal. Okay, and the reciprocal of 1/2 in this case, of course, is 2. Okay, so whatever I do to one side, I need to do to the other. Okay, so I multiply 1/2 A times 2, and then 8 times 2. And then at the end I'm left with A equals 16. So 16 represents her original allowance. Okay, and that works out if you took 16 and then you subtract half of that 16, because she used half of her allowance. Then there you have, she has 8 of her allowance left over, and then she got an extra 4. And if we added that 4 back, that would be 12, and that's what she would be left over with. Okay, so it all checks out. Okay, and this C, of course, I'm not sure why they throw this in, but they want to throw this word context. Okay, but anyway, it says explain your answer in the context of this problem. Well, the question that was asked was, what is Charlotte's original weekly allowance? And that's exactly what this is. So this is Charlotte's weekly allowance was $16. Okay, so that's how you would answer that question. So explain your answer in the context of this problem. Here's my answer here, and what my answer means is Charlotte's weekly allowance was $16. Okay, so here's D, still with Charlotte. And it says here, Charlotte's goal is to save $100 for her beach trip at the end of the summer. Use the amount of weekly allowance found in Part C to write an equation to determine the number of weeks that Charlotte must work to meet her goal. Let W represent the number of weeks. Okay, so here's the information. We have all the information we need. We know she wants to save $100. Okay, now the allowance that the weekly allowance we found in Part C, remember, was $16. Okay, so we have that, and we're going to let W equal the number of weeks. Okay, because that's what we're trying to solve for. Okay. So let's go ahead and have you figure this out, okay, or try to work it, mull it over. Again, we're trying to find out the number of weeks she's going to need to work to meet her goal. Okay, so give it a whirl and come on back. Okay, well, hopefully you didn't find this one too tricky. It might be a little bit different than the ones that we've done in the past, but very simply, she makes $16 a week. We know she makes $16 a week. Okay, we figured that out there. So that would be represented here. So $16, and W, of course, is the number of weeks. Okay, is going to equal 100. So we want to know how many $16 weeks is she going to need before she gets to $100. So we plug in what we know, because 16, so the money she makes times the number of weeks is going to we want it to equal 100. Okay, so in order to do that, of course, we have this set up. We need to get W down to 1 W, and the way to do that, of course, is to multiply whatever we have there by the reciprocal, and the reciprocal of 16, reciprocal or inverse, right, is 1/16, and then we do the same thing over here. And if we go ahead and divide 100 by 16, we end up with $6.25. So Charlotte would need $6.25. It's not $6.25. Excuse me. That is not a dollar and cent figure. That is a week figure. So 6.25 weeks, or 6 1/4 weeks. Okay. And figuring out 1/4 of a week is kind of difficult. Anyway, so she couldn't do it in 6, but she could do it in 7. Okay, so she'll need 7 weeks of allowance to get her to $100, and of course we could prove that over here, because 16 times 7, what is that? That is $112, whereas 6 weeks of allowance is only 96. Okay, so she couldn't make it in 6 weeks. But she would need a full 7 weeks to get, well, at least 100. Again, like I said, 6 1/4 or 6 1/4 weeks. Kind of silly, because you get paid at the end of the week. So, if you see what I mean. Well, actually, with that, then this E here, in reading it, looks like I got ahead of myself a little bit. But anyway, it said, in looking at your answer to Part D, and based on the story above, do you think it will take that many weeks for her to meet the goal? Why or why not? And like I had mentioned, that she can't do it in 6, because that's only going to get her to $96. But she can do it in 7, again, because you get paid at the end of the week. And she can do it during the summer, because generally our summer vacation is about 10 weeks. Summer vacation, so 7 weeks she'd be able to do it. She'd be able to make it. All right, so travel baseball team. This exercise number 3 will take us right to the end here, but it has many different parts up to part I. Okay, so let's take a few at a time as we go along here. All right, so let's go ahead and read it here. We have Alan is very excited about joining a travel baseball team for the fall season. He wants to determine how much money he should save to pay for the expenses related to his new team. Okay, so players are required to pay for the uniform, travel expenses, and meals. Okay, so this is what they need to pay for: uniforms, travel expenses, and meals, which sounds realistic. Okay, that's our basis. That's where we stand. And part A asks this: if Alan buys 4 uniform shirts at one time, he gets a $10 discount, so that the total cost of 4 shirts would be $44. Okay, your task here is to, of course, start with writing an algebraic equation that represents the regular price of one shirt. Okay, solve the equation here and write the reason with the if-then statements. That's not so important to me, but just so you know how to explain it. Okay, so again, he's got these 4 uniform shirts. He's buying them at one time. You get a $10 discount on each shirt. Wait, hold on. So he gets a $10 discount. Okay, so I guess the $10 discount is a one-time discount, not per shirt, but just one-time discount. So the total cost is going to be $44. So here's a few things you have. You have total cost there. You know how many shirts he's going to buy, and then you know his discount. Okay, so go ahead, and what we're trying to find is the regular price of one shirt. This is what we're trying to solve for. Okay, so go ahead and come up with an algebraic expression or equation, and solve it, and come on back. Okay, so here we are. We show you all these different parts of this problem are represented. The 4 uniform shirts were right here. That's 4S. Okay, it shows my S as being standing for shirts. Makes sense. Now I have a $10 discount, which is going to be minus 10. Okay, minus 10. I could also write that as, of course, plus a negative 10, which in this case might be a little bit more helpful, okay, because that's a discount, kind of almost like adding a discount, all right? And that's real important that it is a negative 10, okay, equals 44, because that's what he ended up paying right there, the 44, okay? So the way we solve is, again, we're going to use the, now we're using the addition property of equality, or so we're adding the inverse of negative 10 now, okay, because we have a negative 10. We need to add its inverse. Before we always had positive numbers, so we added the inverse, which were negative numbers. We're just trying to make this number on this side go away, okay? And then the way it goes away or becomes 0 is by adding its inverse, all right? So whatever we do on one side, we have to do on the other, and you got to remember now, we have added 10, okay? And this, you guys, some of you may have done this incorrectly, because this is where it gets a little bit tricky, but it's not tricky if you always think inverse operation. Inverse, okay? Always thinking inverse, not just subtract away, because you're not. Because sometimes you're adding, and in this case you are adding. Which makes sense, because you have a discount on this side, so you're going to add that discount back over here when you're trying to figure out what the regular price of the shirt was before the discount. Okay? It just makes absolute sense, okay? There we go, and after we do that, we end up with 4s equals 54. And then if we do our division, we know that s equals 1350. Okay, and the way I did that division, I don't want to, I would have gone, remember I would have done 1/4 times 4s and 1/4 times 54, or dividing both by 4, okay, which is the same. And then I get that. Okay, and B asks us, what is the cost of one shirt without the discount? And of course that was the answer that we came up with down here, which was $13.50. Okay, so we have $13.50. All right. Okie doke. And now C is asking us, what is the cost of one shirt with the discount? Okay, so with the discount. Now we have to do a few things. So now if we're going to go ahead, well actually why don't you go ahead and see what you can do with that. Figure that out, and again go back to your original problem use those figures there, come back, and we'll do it together. Okay, well, this is, hopefully you found this to be pretty simple. If you just go back to our original information, we know that he paid, $44, okay, for 4 shirts. That's pretty much what he did. Okay, so all we needed there was 4s, 4 shirts equals $44. And then, of course, we just go ahead and multiply that by the reciprocal, getting that down to 1s. So 1/4 times 4s, should have been 1/4 times 4s there, okay, equals 1/4 times 44. And, of course, 1/4 times 44, or 44 divided by 4, is $11. Okay, so he paid, with the discount, he paid $11. Without the discount, he would have paid $13.50. So we can then go ahead and answer D, which asks us how much more do you pay per shirt if you buy them one at a time, okay, rather than in bulk, because with this problem he bought 4 at a time in quantity purchase. I wouldn't call that bulk. Bulk is usually quite a few, maybe a whole team's worth, but anyway, how much more? Pretty simple. Okay, you just take your $13.50, which you paid up here, that's without the discount, buying 1 at a time, minus 11, which is your price when you buy 4 or more at a time, and that equals $2.50. Okay, so you saved $2.50 per shirt. Okay. Okay, this next part is fun, adds a new little twist that hopefully you guys will have fun with, and you may find there are alternate ways of writing these equations. Okay, so here we go. So Alan's team was also required to buy 2 pairs of uniform pants and 2 baseball caps, which total 68. A pair of pants costs $12 more than a baseball cap. $12 more than a baseball cap. Okay, so go ahead and write an equation that models this situation, and go ahead and let C represent the cost of a baseball cap. Okay, so we're going to solve for a baseball cap. Okay, but right now, just this first part, just write an equation. Don't solve anything. Don't solve anything yet. Just an equation. Okay, so go ahead and wrestle with that, and come on back. Okay, so this one, I'm imagining some of you had to mull this over. Maybe didn't quite get to this point where I am right here. So the reason they gave you this, they said C. Let C represent the cost of a baseball cap, is that you're going to solve for C. So you're actually going to represent the pants as well using C. And I know that might have been a confusion, and it is really a next step in your maturity level with these problems. So the way you would do it, and again, a good way to start, is that you have 2C, okay, because you know that you have two baseball caps, all right? Now, each of the pants, because a pair of pants costs $12 more than a baseball cap, that can be represented as C plus 12, okay? Because you have the cap plus another $12 equals the cost of a pair of pants. So if you did that and you saw that, congratulations. If you didn't, don't worry. This is just the beginning of many more of these. But then you would multiply that whole thing by 2 because you want 2 pants. So this C plus 12, this actually stands for or represents a pair of pants. Okay, that's a pair of pants. Here's a cap. Okay, and you got 2 of those caps, and then you have 2 of those pants. All right, and that equals 68. So yeah, that's where we start off with. That would be our equation to begin this problem. Okay, and why don't we go? So F here asks us to solve the equation algebraically to find the cost of a baseball cap. You know, write the reason, blah, blah, blah. Okay, so if I start off with this, and you know, this could be written a different way, but we're going to just stick with this one right here. Okay, because you can represent this equation differently. So if you might have come up with something that looked like this. And again, I'm just going to put these here just briefly. You could have actually done something like that. Okay, 2 and then 2c plus 12 in parentheses. All right, because you can see you have these 2c's equal the 2 caps, and then the 2c plus 12s, okay, right here equals the number of pants. Okay, that would have been one way, but we're going to go ahead and just use this way right here. All right, so if I do have this, what I want to do is I'm going to go ahead and solve for what's in the parentheses first. Okay, so I'm going to take that down. So I'm going to keep this 2c here, plus, and then I have, remember this is, I'm just going to go ahead and distribute here, plus 2c plus 24 equals 68. And now, like we had talked before, we are going to combine like terms. So I'm going to put these two c's together, and that would equal 4c plus 24 equals 68. So now I've gotten to a point, and you might have actually been right here before. Okay, that might have been. That's another place you could have possibly started from. Okay, if you had figured that out. But now that I am here, I can go ahead and apply some of my properties. Okay, and I can go ahead and do 4c plus 24, of course minus 24, because I'm trying to isolate that c, equals 68 minus 24. And now I have 4c equals 42. Okay, and now of course I'm going to do my inverse of 4 to get this down to 1c equals 1/4 times 42. Okay, and let's see, did I do my math right? I did not. Hold on a second. Of course, very simple things you do incorrectly. Okay, that should be 44 there. Okay. All right, so now I'm down to right here, 1/4 times 4c equals 1/4 of 44. Again, that's dividing them both by 4, which means c equals 11. Okay. Now my c equaling 11, of course, means that that is the cost of my cap. Okay, the cap cost $11. Okay, and now G, not wanting us to get away from our tape diagram quite yet to check our work. And if you did put this tape diagram together, I took my two C's from here and I put them right here, C and C. And then I had two C's right here, okay? So then I had another C and a C. And then I had two 12s right over here because there's two of them right there, two 12s. And boom, boom, boom. Okay, so I know that all of that was equal to 68. Okay, 68, this entire thing was 68. And if I know the entire thing is 68, and I know I have these two here, which are 24 already, subtract those away. 68 minus 24. Okay, and that equals 44. And then I have how many C's? 1, 2, 3, 4. And divide my 44 by those 4, and that would equal 11. Okay, so each one of those would be 11. Alrighty. Alright, well the cost right here, letter I is asking us, no, sorry, H, first of all, is asking us what is the cost of a cap, and we had that already right here. Cost of a cap is $11. Alright, but then to figure out the cost of a pair of pants, of course, we would just take that $11 that we know, and we know that the pants were, from the problem, $12 more. Okay, and then we add 12, so that would equal 23. So a pair of pants cost $23. Okay, so here in closing is our lesson summary. And lesson summary here states equations are useful to model and solve real-world problems. And the steps taken to solve an algebraic equation are the same steps using in an arithmetic solution. Okay, and we saw that when we compared the tape diagram, which was pretty much solely arithmetic. You're looking at it diagrammatically and algebraically. Okay, so they aren't. It's not like some strange kind of rocket science. This algebra. Okay, it just makes a lot of good sense. Lots of good sense. Now, the key to solving word problems and coming to understand how to go from a word problem and solving it algebraically is to look for key words, key statements. Okay, so we can go back let's just go back real, because these are going to give you hints as to what to do. Okay, so for example, if we go back, let's go back all the way maybe to the first one, the youth group trip. Okay, there were some key words in here. So it said the youth group is going on a trip to an amusement park, another part of the state. The trip costs each group member $150. Okay, so we know total cost is $150. Okay, $85 on the hotel and a 2 one-day combination and meal plan pass. Okay, so the cost of the trip then, okay, we know that we had the total was $150. We know to put that over here, okay, because it says it cost each member $150. We knew that it was $85 already. We had that for the hotel, but we didn't know the plan pass. We know we have 2 of those, so that equals the 2p, and therefore we have our equation. Okay, let's see the one here. This one here with Charlotte's allowance. We know she had spent half of the allowance, so she only has half of it left. Okay, there's an additional $4, so you add. Okay, additional makes sense, right? Adding 4, and you know she ended the week with 12, so that's what she had. So this half of her allowance plus that 4 additional she got equals the 12 that she ended up with. Okay, so again, those key words and phrases, key statements, that's really important to look for when you're trying to write that equation, because that is absolutely the secret. The secret is writing a good equation. Here's the secret. Start with a good equation. Okay, a good equation. And if you are a little uncertain if that equation is good, create a tape diagram, and maybe that could help you out and help you see it a little more clearly. There's no shame in using the tape diagram for as long as you need to. Okay, well, I hope you enjoyed this lesson. This is the last lesson in Module 2. We'll begin Module 3 after the break. And so go ahead for now. You're going to finish your problem set, exit ticket, and then do the end of module assessment at home. Okay, and when you come back, we will have another end of module assessment just to see where we are all at. Okay, good luck to all of you.